All right, we got a presentation here coming from OPNAV 5119, your Navy Safety Occupational Health, Chapter A4, Hazard Control and Deficiency Abatement. All right, so when there's a hazard present, we have four principles of hazard control. You might also see it referred to as hazard abatement. So those four principles in order of preference and in order of preferred application are substitution, engineering controls, administrative controls, and personal protective equipment. Okay, so those four principles of hazard control: substitution, engineering controls, administrative controls, and then PPE, the least preferred. So we'll talk about each one of these individually on the next couple of slides here. So starting with substitution, when we have a hazard present, the preferred way to deal with it is to try to replace some sort of part or some sort of process or some sort of material that will lessen the severity of that hazard or the probability of some sort of injury or accident occurring. So substitution, just replacing a process. Anytime we want to substitute anything, we've got to get approval, and we got to get approval from ComNav Sea Systems Command or ComNav Air Systems Command as appropriate. And then if we're going to do something that involves our MRCs, our maintenance requirement cards. Okay, so these are cards that are used for maintenance for the planned maintenance system. So if we're going to change, and these cards have like a step-by-step, all the tools you'd use for any kind of maintenance, and a step-by-step procedure. So if we want to use substitution that involves a maintenance requirement card, we've got to submit a feedback report. So we got to submit a PMS feedback report, or PMS FBR, a planned maintenance system feedback report, if we want to do any kind of substitution on an MRC, on a maintenance requirement card. Engineering controls. So engineering controls is accomplished primarily through design and advanced planning. It's designing, something with the equipment that may be hazardous to kind of mitigate that hazard, to kind of decrease it. Whenever these methods are used, the safety officer or the industrial hygienist should approve prior to implementation. And when we talk about engineering controls, we're going to talk about two specific types. We're going to talk about isolation and ventilation. So isolation is the physical separation of a hazard from the personnel, working on that piece of equipment. So what we're talking about here is like machine guards on any kind of machinery, or electrical insulation, sound barriers, so equipment's not as loud, it doesn't produce any noise hazards, or using remote control equipment, using equipment where you don't have to have the person in that hazardous environment. Those are examples of engineering controls, and more specifically, isolation. Then ventilation, we split into two types. We got general/dilution ventilation, and then we have local exhaust ventilation. So general and dilution ventilation, that's just putting more air in the room. But we're mixing in quantities of uncontaminated air. So we're just diluting the air in the room. So we only really want to use this like to control heat, because remember, heat's considered a hazard. And we actually have a chapter in our 5119 on heat stress. So we can use general ventilation to kind of reduce that heat and humidity, or if we do have a toxic material, it's got to be low toxicity. We don't want to use it in something that's super toxic, okay? That's where we want to use local exhaust ventilation. So local exhaust ventilation is removing an airborne substance at the source, at the point of generation. So if you have something that's producing some sort of toxin, it's getting removed right there where it's being produced. And that's the preferred method, right? It's more economical, and it's preferred to do local exhaust ventilation, to remove that, to have some sort of ventilation that removes that toxin right when it's produced, rather than general/dilution ventilation, which just pumps fresh, uncontaminated air. So any ventilation requirements, you're going to get those requirements through the industrial hygiene survey, right? Every command, ships included, they have an industrial hygiene survey, and they're supposed to have a current survey on board, and that will determine what type of ventilation is used in what type of space. So substitution was our preferred method. After that was engineering, and now our third type of hazard abatement or hazard control on that list, administrative controls. All right, and we're going to define it as administrative controls as employing special operations or procedures to reduce the exposure of individuals to a hazard. Examples include limiting access to high hazardous areas or adjusting work schedules. So just cutting off access, just saying, hey, you know what? The space isn't mission essential right now, so we'll just cut off access to it. Or like changing your shifts, like not having people work during the hottest part of the day, changing how long the watch is in that, that really hot room, but just that's considered administrative control. Changing schedules, changing access, that would be an example of administrative control. And then our least preferred method, personal protective equipment. And the reason this is the least preferred, because you have the risk of equipment breakdown, failure, or just flat out misuse. People not using their PPE appropriately, like hearing protection. That one's commonly not used appropriately. It's commonly not inserted the correct way. So there's a high potential for user error with personal protective equipment. So that's why it's our least preferred. And anytime we have PPE, it requires training, right? We have to have like annual training for hearing conservation, annual training for or annual fit testing for respirators. So it requires training, maintenance of the PPE, and then the user's got to accept it, right? They've got to use it appropriately and know that they have to use it, that they've got to put their hearing protection on when they go in a noise hazardous area, or they've got to wear, this type of respirator when they're working in this kind of environment. So there's a high potential for user error, so that's why PPE is our least preferred method. So a quick recap on our principles of hazard control. We had substitution, we've got engineering controls, administrative controls, and then our personal protective equipment, our PPE. And that's the order of preference. Substitution, we said anytime we want to substitute anything, we've got to make sure that we get approval from ComNav Sea Systems Command or ComNav Air Systems Command. Our engineering controls, we said we're going to talk about isolation and ventilation, and then ventilation even drilled down into general dilution ventilation or the preferred local exhaust ventilation. Administrative controls, that's just controlling our access or our schedules in the hazardous area. And then PPE, that was our least preferred method of hazard control, mainly because of user error, but then there's maintenance and training that goes with that as well, and it just makes it the least preferred way to deal with a hazard. So a quick review of what we covered so far. In order of preferred application, what are the 4 principles of hazard control? So those 4 principles of hazard control were substitution, engineering controls, administrative controls, and then our PPE. Which method of hazard abatement employs special operating procedures to reduce the exposure of individuals to hazards? All right, special operating procedures to reduce your exposure. Well, that's an example of an administrative control, right? Changing access, changing schedules, that's all a special operating procedure. Machine guards, electrical installations, sound barriers, and remote controlled equipment are examples of what method of hazard control? Machine guards, electrical installations, sound barriers, what type of hazard control are we talking about? Well, we're talking about isolation, which was a type of engineering control. Okay, so that's an example of isolation, which falls under engineering controls. Who must be contacted for substitution approval? If we want to substitute something, who do we got to contact? We've got to contact ComNav Sea Systems Command or ComNav Air Systems Command as appropriate. Which method of ventilation is preferred and more economical? Which method of ventilation is preferred and more economical? Well, that's going to be our local exhaust. Local exhaust, removing that toxin right at the source of generation. What is submitted in order to replace a tool or material on a maintenance requirement card? Remember that maintenance requirement card, how we do our planned maintenance? It's a step-by-step procedure, lists the tools, lists the safety considerations. So if we want to replace a tool or any kind of material on that, we've got to do a feedback report, right? We've got to do a planned maintenance system feedback report, a PMS FBR. What method of hazard control is the least preferred? What method of hazard control is the least preferred? Well, that's PPE. And again, user error, training, all that stuff that plays into it. All right, so hazard abatement program procedures. Shipboard hazards that cannot be corrected on the spot, they got to be documented. And the place we're going to document them in is what's called the Work Center Deficiency Log Job Sequence Number, okay? So the WCDL/JSN, Work Center Deficiency Log Job Sequence Number. So the safety officer will provide results of workplace inspections, industrial hygiene surveys, and safety hazard reports, and our hazard report's going to be done on an OPNAV form 3120/5. All right, they're going to make sure that the division officer in charge is aware of this, okay? They're going to make sure they get this information to the division officer of that space. The safety officer is going to maintain a documentation of hazard controls through inspections, surveys, or as reported to individuals. And what they got to do is they got to assign a risk assessment code, or a RAC, of all documented hazards. And we're going to talk about risk assessment codes in just a little bit here, get a little bit more detail on those. All right, and then a HazRep is used to notify others outside the command of any kind of hazard, and that's going to be completed by the safety officer using what's called the web-enabled safety system. Okay, so that web-enabled safety system, and that's something that comes up a couple more times throughout some of your advancement training. Like it comes up in hearing conservation, it comes up a few times throughout the 5119. All right, so let's talk a little bit more about that risk assessment code. Your risk assessment code is, again, assigned by the safety officer. Any identified hazard they've got that they can't correct right there on the spot, they've got to assign a RAC to it. All right, and what the RAC is it's going to provide a measure of the degree of risk associated with that deficiency, with that hazard. So what it's going to do is it's going to take the severity of the hazard, like how bad could it be if it happened to somebody, and then or if an accident happened because as a result of that hazard, and then they're going to take the probability, how likely is it to occur. So with the severity and the probability, that's how we get a risk assessment code. Right, so severity and probability, we have a scoring system. For severity, we're just going to go 1 through 4, just the Roman numerals 1, 2, 3, and 4. And for a level 1 severity, we're going to say that's catastrophic. Okay, level and when we say catastrophic, this is something, if it occurs, right, if the hazard is so severe that it's probably going to cause death, right, a loss of the faculty or the asset, or can result in grave damage to the national interest. Level 2, well, that's going to be critical. Something critical, we're going to say, may cause severe injury, illness, property damage, and damage to national or service interest. So damage to the nation or damage to the Navy. All right. And then a level 3, well, we're going to say that's marginal. The severity of that is marginal, and that may cause a minor injury, illness, property damage, damage to national service or command interest. And then 4, we're just going to say that's negligible. All right, minimal threat to personal safety or health or property or national service or command interest. That's, it's the least. It's negligible. It's probably, if it, the hazard is just going to cause minor injuries, that shouldn't be a huge issue. All right, so severity, 1 through 4, catastrophic, critical, marginal, and then negligible. Mishap probability, we have 4 categories of that as well, but we're going to do it in letters, A, B, C, D, right? Alpha, Bravo, Charlie, Delta. So alpha, we say it's likely to occur immediately. Okay, so when we start working in this hazardous environment that we've identified, the hazard is likely to have an effect immediately, as soon as we start working. Bravo, it probably will occur in time. So if we're working there for a couple hours, we're probably going to have a mishap working in this hazard. And then Charlie, it may occur in time. And then Delta, it's unlikely to occur. So as we go up the alphabet, it becomes less and less probable. So like we were saying before, right, to get that RAC, that risk assessment code, we got to take the severity. So we got the severity over here. Remember our severity 1, 2, 3, 4, right? If the injury would be catastrophic, critical, marginal, or negligible. And the probability, right? It's likely to happen immediately, probably will happen in time, may occur, or unlikely to occur. So we take these two things, we take the severity and the probability, and we assign a digit, a single digit, a number. So you can have a RAC of 1, 2, 3, 4, or 5. Okay, and that's how we're going to express the RAC, as a number, and with 1 being the most severe. So 1, right, a RAC code 1 would be anything that's going to cause a catastrophic injury if it happened, going to be result in death or damage to national interests, and it's likely to occur or probably will occur in time, or it's critical and likely to occur immediately. Okay, so likely to occur immediately for 1 and 2, right, and also if it's going to occur in time, that'll make it critical as well. So we call it a critical safety or health deficiency, and it's got to be corrected as soon as possible. This is things like electrical shock injuries, missing or damaged lifelines, or inoperable escape scuttles. A RAC level 2, well, you see, we start to become either less probable, right? So we're over here in Charlie, which was may occur, and it still be catastrophic, but the probability is decreased, or it's critical and it may occur in time, or it's marginal, right? A 3 is marginal, and it'll probably occur immediately, but it's marginal. So we assign those as of a RAC code of 2, and we say this is a serious safety or health deficiency. RAC level 3, what did you see? It just kind of moves its way down, right? RAC level 3, moderate safety or health deficiency, and then our RAC level 4, what we say a minor safety or health deficiency, and then a RAC level 5, negligible safety or health deficiency. And that's how the RAC codes work. Okay, so the big thing to take away is just the RACs are expressed as a single number, and what they're doing is they've got this grid laid out, and you take the probability and the severity, right? If it happened, how bad it would be, and then how likely is it to happen, and that's how you get a risk assessment code. All right, so just to review those risk assessment codes real quick. We said 1 is a critical, 2 is serious, 3 is moderate, 4 is minor, and 5 is negligible. 1 and 2, CO's got to be notified, okay? A RAC level 1 or 2, the CO's got to be notified, and the CO is going to approve some sort of interim protective measures or determine somebody to approve some sort of type of interim protective measures, something in the meantime to kind of until we can get this hazard that we've identified into a lower RAC or get it controlled completely. All right, so real quick right here, I got a copy of your OPNAV 3120/5, your safety hazard report with what the safety officer would fill out if there's any identified hazards that they can't get corrected on the spot. And you can even see it's got on the back of it, it's got that RAC, those RAC codes on it, right? It takes the probability and it takes the severity. Right, and then it even lets you know critical, serious, minor, negligible, a little bit more detailed in the actual instruction than this form. All right, a little review of what we covered. Where are hazards that cannot be corrected on the spot documented? If we can't control a hazard on the spot, we got to document it in the Work Center Deficiency log, the job sequence number, the WCDL JSN. What form is a safety and hazard report? What form is a safety and hazard report? Well, we're just looking at it. The OPNAV 3120/5. What is derived from the elements of the hazard severity and the mishap probability? So if we take how severe the hazard can be and we take the probability, what can we get? We can get a RAC. We can get a risk assessment code. How many risk assessment codes are there? How many RAC numbers are there? Well, there are 5 RAC numbers. What are the 5 risk assessment codes? So we said 1 is critical, 2 is serious, 3 is moderate, 4 is minor, and 5 is negligible. What are the letters assigned to probability? So when we're thinking of mishap probability, we take letters A, B, C, and D, and A means likely to occur immediately, B means probably will occur in time, C may occur in time, and D unlikely to occur. What are the hazard severity categories? So remember, severity, we did numbers. 1, we said catastrophic. 2, we said critical. 3, we said marginal. And then 4, negligible. All right, this wraps up this presentation. Again, this is coming from your Navy Safety and Occupational Health Afloat, the OPNAV 5119 Echo, and this is Chapter A4, Hazard Control and Abatement. As always, I hope this is helping you out, and keep studying.